Good morning, children. Hopefully, you all are keeping well. Children, yesterday we have done indicators. I hope you must have made your own indicators and have observed that what type of the color changes take place with the help of litmus paper as well as the colored paper. With the help of China rose, you must have made your own natural indicator. Now children, you have to fill table 2.1 after going through that video once again. Table 2.1, in that you have to fill how the color changes take place. Is it clear? This table, right? Now today's topic is how metals react with acids and bases. Activity 2.3 indicates that in a test tube in apparatus as shown in the figure, we have taken a test tube, and in this test tube we have added zinc granules. In zinc granules we have added small amount of dilute sulfuric acid. Any acid we can take here. We can take hydrochloric, nitric acid or acetic acid. So for example, here we have taken dilute sulfuric acid. When we keep it for some time, we observe that gas bubbles are seen at its surface. Do you remember the same activity we have done in chapter 1 also? That was activity 1.2. This is the same activity, children. So gas bubbles are observed above the zinc granules. This gas bubble is passed through delivery tube to a soap solution, and this is a colorless gas. As it is colorless gas, we cannot see the bubbles coming out. It will not be clearly visible. So what we have done, we have passed this colorless gas through the soap solution, liquid soap or detergent solution we have made. Just like as you were small children, you used to play that game with water bubbles. Do you remember? Detergent wala solution, and you used to make big bubbles. Same way, the big bubbles will be formed as the gas will be making big bubbles. We will bring a burning matchstick to check what gas is being evolved. Children, remember, there is always a distinguished characteristic or a test for the gas evolved in a chemical reaction. Here the gas evolved was hydrogen gas. So hydrogen gas characteristic can be checked by bringing a burning matchstick near it. I would like to tell you here that this is a physical test. This is not a chemical test, because we are bringing a burning matchstick or burning candle near the gas bubbles. It will cause a pop sound. So this will indicate that hydrogen gas is evolved. Now let us observe a video for this.
Children, now onward in my videos, wherever I want to show you some practical activity, I will add a link for that video in the description box, so you can watch those videos, because technically we can't put these videos along with our video. So as you know, these are the legal issues. So I'm not going to put the videos in my video now onward. You can check in description box and watch those videos, enjoy and very well understand the concept.
We have seen distinguished characteristic test for hydrogen gases. Bring a burning matchstick near the gas bubbles. Gas will burn with pop sound. Right? So this is hydrogen gas test. In this chapter, one more important thing I would like to tell you is that at the end of each activity or at the end of each reaction, there is summary. Like here, this is the first reaction, acid plus metal. means word summary is there. So you need to remember this word summary, because metal may be any metal like high reactive metals or medium reactive metals, and acid may be any acid. Nitric acid will not be seen in these many reactions. Why? That we will discuss later on. Here we will use HCl, we may use sulfuric acid H2SO4, hydrochloric acid HCl, we may also use acetic acid, that is CH3COOH. So acid plus metal will give us salt. I would like to make a correction here. Metallic salt. Write down, instead of writing salt only, write metallic salt. So acid plus metal will give us metallic salt plus hydrogen gas. I would like to show you these reactions with some other acids. The same reaction take place with acetic acid with sodium, because acetic acid is a low reactive acid, it is a weak acid, so we will take strong metal, right? So we have taken sodium, which is a strong metal, high reactive metal. Sodium reacts with acetic acid or ethanoic acid. I have written here clearly, acetic acid is the common name and IUPAC name is ethanoic acid for CH3COOH. And I have indicated clearly CH3COO, acetate ion, is minus negative charge, and H ion here is at the end, like we have seen in HCl. In HCl, H ion is in front. In nitric acid also, H ion is in starting. H2SO4 also, H ion is in starting. You can see here, HCl have H ion in starting. But in acetic acid, H plus ion or H ion is at the end. Okay, so do remember this thing. H ion is at end in all the organic acids. So ethanoic acid plus sodium will give sodium acetate, which is common name, and sodium ethanoate is the IUPAC name. Sodium acetate is the common name and sodium. So we were talking about sodium plus ethanoic acid reacts and forms sodium acetate. Sodium acetate is the common name, and sodium ethanoate. This is salt. As we discussed, it forms metallic salt plus water. So salt is sodium acetate plus hydrogen gas. Okay. Now similarly, reaction of acetic acid with lead is CH3COOH plus lead gives lead acetate or lead ethanoate, right, plus hydrogen gas. Same reaction take place with base as well. Base, like NaOH, when react with zinc, it forms a salt, sodium zincate plus hydrogen gas. So I hope you are very clear about this, that when acid and a base react with metal, they form metallic salt plus hydrogen gas. I hope you are clear. So do take care of yourself. Goodbye.